Okay guys, so really sorry I'm gone again. Medication went on, makes me very lightheaded, get headaches, all sorts of fun stuff, so I ended up not being able to stay. We are still going to do that banana activity we originally talked about doing coming back from spring break, even though I wasn't there. So you need to get into groups of 2 or 3 people, pause the video now, take like not even 2 minutes to do that. You're adults, you can do it. Okay, so there is a bag of bananas. They are already cut in half for you. So what we're doing is we're going to use these to help visualize what our volumes and solids that we're finding look like. So I've taken a banana and we're cutting it kind of a weird direction. We're cutting it this long way. Some of them were cut better than others, so pick wisely. If you look at it, we're basically taking it, splitting it in half here. So if you want, you can leave the peel on or you can take it off. It is totally up to you. We have our half a banana. So set that aside for right now. You also need a piece of paper. So there should be some extras in the room for you to use if you need one, along with some plastic knives. So make sure you get a piece of paper, your half banana, and then a plastic knife. On your paper, it doesn't need to be beautiful, but you're going to draw yourself an X and Y axis. Okay. With your X and Y axis, what you're going to do is you're going to take your banana and set it down on those axes. So, it's going to get kind of sticky on your paper. Don't worry too much about it. What you need to do is go and find about 10 different points on each side of your banana. So you're going to just put some dots along your banana, get an idea of what its shape is underneath. So we have this solid. We're going to find what the graph underneath looks like. So now, when I think about my banana, well, it has this 3-dimensional shape here. When I take it off though, those 2 lines, well, they kind of look like a certain type of function. What function do we know of that has a shape like this? Take a second, write it down, talk to your neighbor. I don't know if you were, but I'm hoping you guys were thinking quadratics. So what you're going to do is take out your notes for me. You're going to be on lesson 5. So we have a banana, we have it face down, we've graphed it. I don't know entirely what the Eduardo voice is, but Eduardo, I'm trusting you to do that. So now that we have all those points, we have the top and bottom part of a banana. These look like quadratics. I don't have the fancy technology to send this to your calculators, so even if I was there, we'd be kind of going through this in a different kind of way than what they do at Southeast. We're going to use the data from another group of students just to make this go a bit easier, and so that way we can actually compare our answers with each other. So if you flip to the next page here, I believe it's page 22, it has the data points on here with the graphs for you to see it. All you're going to need to do is type in the equations they got out. So the 2 equations here, F1 and F2, are what you need to type into your calculators on a graph. So what you're doing is you're going to go to your calculator, type in that function. So pause the video now if you need some time to do that. Okay, so on your calculators, what you should see when you graph them are these 2 graphs here. It's a little hard to see in the document camera. There we go. Okay, so you should see these 2 graphs. Now what we're going to do is we're going to answer a few questions in our notes. So if you look at your notes, in your notes it says for the first question, what type of cross sections do your banana have? So what we're going to do is we're going to take that plastic knife I have a real knife because I'm at home. And you're gonna put your banana back on to your quadratic. What I want you to do though is, if you haven't yet, take the peel off. So that's gonna help us a little bit here. Just to get a better shape for our semicircles. So what you're gonna do is you're gonna take it and you're just gonna cut out any little section in your banana that you want here. Now go ahead and pull out that cross section. And what shape do you have? Go ahead and write that in your notes now. If you have your little slice ready, write that into your notes. So you should be writing that this is a semicircle, because it's half a circle, about, depending on how well your banana was cut. So you could do that with any cross section in this banana, no matter where we are. So if I look here, next to it, okay, that's still a semicircle, still a semicircle. If I look over here, we still get a semicircle. Okay, so the next question it asks, if you look at your notes, I'll pull that up for you, is what geometric formula would you use for the area of the shape of any cross section? So remember, our area for a circle is going to be pi r squared. So if I want to know the area of a semicircle, we're going to divide that by 2. So go ahead and write that geometric formula into your notes there. That's for number 2. Okay. For 3, it says, what is the setup for the integral that you would use to find the volume of the piece of the banana you have? So that's this whole piece of banana. We are looking at this banana, we say, okay, I have all of these. If I put these back into their chunk parts, what is the whole area of this half a banana that I have? That is what we're doing with our integrals. We're saying I have a solid, its base is the shape of those quadratics. What is its shape? So this is where our calculator is going to become a bit more helpful for us. So go back to your calculators. And on your calculators, we need some information from them in order to write our integrals. Remember, our bounds are occurring between the edges of our graph. We only care about the area in between. So if I care about the area in between, I need to go from here over to here. So we're looking for what type of point. Go ahead and pause this, write it down, talk to your neighbors if you need. Okay, so you should be saying that you are looking for those intersection points. So for those intersection points, we can find those on our calculator. If you remember, you're going to go menu, zoom, analyze graph, down to intersection number 4. And I care about both my intersections, but remember, you have to find them one at a time. So we have one intersection here, menu, analyze graph, intersection. We need the intersection over here as well. So click, highlight, click again. Now I think some of you were gone when we talked about the little trick that you can use on your calculator if you need to see more decimal places. In calculus, we will always want at least 4 decimal places, so if you don't see 4 decimal places, you need to increase it. What you can do is select and highlight that point and then click the plus sign on your calculator. It'll end up showing you more decimal places than you had before. So I'm going to do that over here as well. Okay. So now that I have my intersection points, it's going to make writing my integral a lot easier. What you can do too is you can store these values later on for when we evaluate it in our calculators. I'll show you how to do that in a second once we know what our integral looks like. So for our graph, we know our intersection points. Our integral is going to be based around those. So for our integral, my bottom bound is going to be based off that first intersection point. I'm going to label that intersection A. All the way up to my second intersection, intersection B. So what I'm saying is I had that graph was a banana shape. This one's A, this one's B. So now the function in the middle though, remember it's going to be based off of my cross sections. Well, our radius in this case is based off of our function that we have. Our radius is that top function minus the bottom function divided by 2. So our radius is going to be our top function, which is f2 minus f1 all over 2, and we're squaring this. And that's multiplied by a pi over 2 as well. So what we'll end up with once we simplify this a little bit is the integral from a to b of a pi over, well, when I take this square, I can distribute it kind of. It affects both the top and the bottom separately. So if I square the bottom here, I end up with a 2 squared, which is 4, times another 2, which is 8. So pi over 8 times an f2 minus an f1 squared. Okay, now that I have this, the only thing I'm missing is over here, dx. Oh, I forgot it up here. Only thing left, a to b, and f2 and f1. Well, that's why we're going to use our calculator to find the actual value. Okay, so I want you guys to take just like 5 minutes, try and do that last part, find the volume using your calculator. What is that volume that you found for their half a banana? Little trick that I talked about is storing those values in your calculator if you don't know how. If I want to store my x value here so I can use it when I'm typing it in, I'm just going to click and highlight that, go Control, and then my variable button. Oh, you can't see that. Ooh. So click here. Don't want in the text. So when you're highlighting it, making sure you're not inside the actual text, changing it. Alright, once it's highlighted, click Control, Store. It'll show up here, and whatever variable you want to store it as. So I called it A, so I'm going to click and type A in here. Click Enter. Now it's bolded, telling me, hey, this number is stored. It's an important value that you have. I can... No, don't. Okay, so my calculator was being really dumb. If yours is not doing it, you can always just write the numbers down to the side and type them into your integral. This is just slightly more accurate. What I like to do once I've done that is I just make another document. So, or not a document, another page. So you can go Control, Document, add a page. We need a calculator. So go ahead, go through, type that integral in. When you're doing that integral, remember, we just stored those values, so if you want to use them, all you have to do now is type in A. It'll be bold, letting you know that, hey, I recognize this, there's a value stored for this. Same thing should happen with B up here. So go ahead and find the value for that integral with your groups. Okay, if you guys need more time, just let the sub know to pause it, and I'm going to write the answer up in just a few seconds. Okay, it should be getting a 9.9612. Okay, so I hope this was at least kind of fun, hands-on. I know it was a little different with me being out of the classroom and recording it, and it's just probably not as exciting as it could have been if I was there. But that's okay.